This is Brian. We call him Hamza, but the streets call him The Limit. And this is Roman. We call him Rishi, but the streets call him The Tendency. And then there's me. They call me Savvy, but the streets call me Deriver. I don't get that. I don't got my Calculus license. But the Limit and the Tendency, they know what they're doing. This is my life. Hey man, what's up?
Yo, Sabi, I'm racing Roman right now. What do I do? Tell me what to do, man. I need help.
Got you. Limit is in a situation. He's currently racing Roman from the same point, which they started at 8 a.m. One of them is traveling east at 50 miles per hour, and the other is traveling south at 60 miles per hour. The question is, at what time will they be 300 miles apart? Here is a diagram to visualize the question. Since the two cars are traveling in directions that are at right angle, let x and y be the distance traveled by the two cars in t hours. X equals 50t, while y equals 60t. Since the two directions are at right angle, Pythagorean's theorem can be used to find distance d between the two cars as follows. D equals square root of x squared plus y squared. We now find the time at which d equals 300 miles by solving square root of x squared plus y squared equals 300. Square both sides and substitute x and y by 50t and 60t. So 50t squared plus 60t squared equals 300 squared, which will give you t equals 3.84 hours, which we're going to round it to 3 hours and 51 minutes. So the two cars were 300 miles apart at 11:51 a.m. You win?
Yeah, thanks, eh?
Alright, no worries. See you later.
Alright, I'll pick you up later. Thanks. Roman, get in.
That wasn't a fair race, bro. Cheated. Not fair.
Oh, yo, Sabi was good.
What's this?
What do you mean? It's my car. What are you saying, huh?
It's an Arab-mobile. All Arab
Yeah.
family man has it.
Like, I don't get it.
Whatever, man. Just get in. Just get in. Yo.
Yeah.
So how's your son doing?
My son, about 2 years ago, he was diagnosed with a condition called chronic DAB syndrome. It's very rare. Like, it's one in 10 million children get that, and it's pretty sad to see that my baby is diagnosed with that. It's hard to live with.
Yo! Brian! Brian!
Bro, is that you? Bro, is that you, man?
I miss you! I haven't seen you in years, fam! Where you been?
Oh, I've been in school with my son, I'm happy.
That's your son?
Yeah,
No way! Is that actually
he's
your
actually my
son?
son. You can see he has this condition. Stop that shit.
Is
Oh,
that-
man. Yeah.
Bro, that's not a condition, that's a gift!
Yo, imagine Hamza's son in math class, bro.
What? What are you saying?
Nah, it's just like in math, like, can anyone explain this graph? Yeah, it's a negative exponential and the tangent. He's like,
Huh?
Alright, so this is easy. What you gotta do, you gotta go straight down on Brian.
Yeah.
Right? Go straight on Brian, you take a right to Lawrence, take a left, go straight down to Brimley.
All the way down Brimley?
All the way down to Brimley. There's
Alright.
no traffic and everything. You said you're bad on the sharp turns, right?
Yeah.
Don't worry about it. No traffic.
Upgrade my tires.
Just drift it. Just drift it. Drift
Okay,
it to the left. You know how to do that, right? Handbrake, e-brake that.
That's all
Left
I
and
do.
the right. You just go
Alright,
through.
yeah.
You go through. Just cut past that. You got this,
And
bro.
just keep on going down until I
Go down Shepherd. The circuit goes until Shepherd, and you
okay.
go all the way down. Go to Victoria Park. Take the bridge over the 401. Just bring it down here and drop it. You're done. You win the race.
Sounds like a plan.
You win the race.
Alright, yeah.
Alright, okay, that's how you do it.
Okay.
That's how you do it. Yeah, bro.
You guys, can you do me a favor?
What?
Yeah.
It depends what it is.
Come on, guys.
Alright, what is it?
I'm going up against DQ.
What's that, Dairy Queen?
Nah, you idiot.
It's derivative queen, DQ.
Oh, okay.
Alright, guys, let's get down to business. No fooling around here.
Okay.
Let's do this.
In order to win,
You gotta minimize time.
Okay, how do I do that?
Alright, fine, I'll help you. So think of it like this. This is your car here, and the finish line is over here. It's 10 kilometers away.
alright, this equation models your race. DQ's record time is 2.8 minutes.
So all I need to do is finish before that.
Are you zooked? 2.8 minutes? Are you stupid? Even I can't even do that in 2.8 minutes, and I've been driving for years.
2.8 minutes? What's the speed on that?
DQ's distance is modeled by this equation. dt equals 2,205 t squared plus 150 over 6. Therefore, DQ's velocity is 2.8 minutes. We need to find DQ's velocity after 2.8 minutes. So you need to find the first derivative of the equation. So d prime t equals 4,410 t plus 0, which equals to 4,410 t. Using the 2.8 minutes, we want to convert that into hours. So divide that by 60. So 2.8 minutes divided by 60 equals 0.0476 hours. Then you want to sub that number into the first derivative equation, which will get 2.10 kilometers per hour.
That's 210 kilometers an hour.
In order to do that,
We need to finish 10 kilometers in 2.8 minutes. So we need to minimize time.
so in order to be dq, the velocity is represented by this equation. F of x equals x squared plus sine 3x. X is greater than or equal to 20. X is time elapsed in seconds. So we want to determine the IRC. When x equals 2 seconds, we want to first find the first derivative of f of x, which equals f prime x equals 2x plus 3 cos 3x. Then you want to sub in 2 into x, which 2 times 2 plus 3 cos 3 times 2. Which equals 4 plus 3 equals 7 meters per second squared.
Exactly.
Got the whole spot going up like that. Lay back, hot in the cut like that. We can turn the dance floor to an elevator in a millisecond. Have it going up like that. We can switch it up like that. Front to the full pack, front to the back. Speaker box blast go rat tat tat tat. In fact, we about to go up like woo. Speaker box blast.
Yeah, Nah, she's gonna ruin it, bro.
She's
Holy-
actually gonna ruin
watch
it,
it, watch it,
bro.
watch it. She's gonna ruin it.
Yeah,
She's gonna
right
ruin
now.
DQ.
Look up of it right now.
She's gonna like.
The river damn that's fast, bro. What do you think the speed's on that?
10x squared plus 12.
What? What do you mean?
X equals 2. Oh, I get it. It was fast. Where's she going?
What the hell? What?
Where's she not?
What are you doing?
I thought I